Hello, and thanks for joining me. Well, we're going to rebuild this Hardinge Cataract turret tailstock. A guy gave it to me, and it was in the process of being modified to fit a 9-inch Cataract, and mine's a 7-inch. They did a fairly good job, but there's some things kind of messed up on it. Let me show you what we got here. Well, here it is. This piece goes right there, and this bar goes on here and pivots like that to move the turret back and forth. This has to be rebuilt, and these pins, these locking pins right here, they're too thick, and it looks like, here, I'll pull one out. These have been made. These are not original. You can tell that a little bit of rough machining there, but that's a very difficult thing to make. It's on an eccentric to move that pin up and down, and it's a very small amount of movement, so I don't want to mess with that. I'm hoping it'll work fine, but these pins are too thick right here, so I've got to turn the end of them off, and I'm hoping I won't have to do anything to this side. But if I do have to turn a little bit off of this side, it's going to be extremely critical to make these pins lock in the lathe bed, just because there's so little movement here. I don't know if you can see that on the camera or not. That's not much of an eccentric right there. So that's the first thing we're going to do. We're going to measure the thickness of this disc in the bed and then take the end of it off. And if we have to, we'll take a little bit off this surface. Best I can tell, this surface is fairly accurate. Anyway, that's what we're going to do now, and we're going to use the Hardinge lathe to do that. That pin's not entirely concentric, but it'll work. Okay, as near as I can tell, it's supposed to be 3/16. I measured the tailstock I have, and that's about how thick it is, so that's what we're going to aim for. Boy, that's slick. Taking 10,000 cut. Oh, perfect, perfect. That's a good fit. I see a problem right now. The orientation of these handles is going to be different. Not a big problem, but it's kind of annoying. Let's go try it out. thing must weigh 50 or 60 pounds. Oh, look at that. I think we should. Now, I don't know if I've got any handles for this. I don't think I do. Let me look in my stuff. Yes, I did. I've got the handles. Now, it's got that bracket that fits on the back. I may have to move that to the other side so that it doesn't interfere. Yeah, see, it's hitting right there. I guess it could hang down there below. Yeah, that's fairly close to parallel. I like it. Okay, I was told that this turret was supposed to move part way like that in case you wanted to keep drilling with the same chuck. You could back up. I could continue drilling, or I could go ahead one. I was kind of wondering if maybe if I pulled back fast, if it would go to the next one. And I think it might if I really went fast, but I don't know that it's supposed to work like that or not. Well, that's pretty slick though, isn't it? But I do know you can go back to the same chuck or forward to the next chuck. You can see that somebody didn't finish drilling the holes here. There's only two here. There's one on this side, and they're different sizes. Right here is a clamp, and that's, if you know how a quill clamp is made, that's how this is made. And it's at a really weird angle, and this is handmade right here, and it doesn't really work right. And to be honest with you, that's some very complex machining right there. So I think what I'm going to do, now let me get the chuck and the mandrel. I'm going to turn this off, put it in my lathe and turn it up in my south bend, and turn it off to about right there. And the new holes fall right on that ridge to make it line up with my chuck. And I'm going to make that hole as deep as I can, and then put a plate on the top of this, bolt it on, and put some set screws that go directly into that. And I may cut some flats on that, but that's way easier than this clamping mechanism. This clamping mechanism is, let me show you if I can get it out. No, I can't get it out. It's like a just like a quill. It's got two halves like that come together. I think right now it's going down too far for this to go in. There we go. So he didn't even drill it far enough to make that fall into there, and I'm not sure he could have drilled far enough. So I got a lot of work to do anyway. But that's probably the next step. Is to, what I'm going to do is put a drill in a collet, center drill, and then run it into the chuck or the drill and mark the holes on this turret. And then I'll put it in my south bend and cut it down accordingly. That's the next step. Here's what I was talking about on that clamp. It looks like the original Hardinge clamp. Of course, I don't have the rest of them. I have to get that pin out in the lower half of it. Do that after I take this turret off the turret, if that's how you say it. I haven't got a socket to fit that. I've had this off before, and it's kind of weird getting it back on. I hope after I get done machining it, I can get it back together. I really don't want to get into the mechanics of this thing. They're very complex. And that's why I didn't want to really remake the whole turret. There's a lot of weird positioning there. Getting that thing centered with this, there's two tapers there, one here and one here. And getting both those tapers to line up right on a new turret would be very difficult. Yeah, I was worried about that. I was hoping this wouldn't run into the jaws, but it is. I need to figure out something here. Some way of holding that. Okay, I got to take this off because it's in the way of the jaws on my chuck. I can't chuck this in there. Hopefully this will come off easy, and hopefully it'll line up right when I put it back on. See, these are at a slight angle and tapered this way. That would be unbelievably difficult to get positioned on a new turret. And I'm not sure how I'm going to get that thing off. Get a wedge under. Maybe I get my pocket knife under it. Oh yeah. Oh, it's broken. Wow. It's broken. That's definitely not a good thing. But maybe it'll work like that. I don't really like that at all, but this is all shattered, broken there, and there. Pinned and screwed, it might be okay. I don't know. Don't like that at all. Maybe I'll super glue it. Wow. That was really unexpected. Like I'm doing. Tell you what, I didn't see the cracks until I went to take it off. Isn't that something? They've been carefully numbered. There's numbers on this piece and numbers on this. So I should be able to get it back the same way. Wow. Unexpected. Okay. Oh, I forgot to get that piece out of there. I got to get that pin out of there and that clamp. Or not. It's going to be hard to get it out. I'll try. Much easier than I thought. Yep. Okay, now we'll turn it down. I turn it down to there. I think what I'm going to do is turn it down so I eliminate the hole on the face, like right to there. Bolt a 1/4 inch steel plate on the top and finish it while it's bolted on the top. So now all I got to do is a lot of turning. Well, it would be nice if I was breaking some chips there. I don't know if I can feed that fast or not. Maybe if I make it a little better. Got a ways to go. I don't have to take off more, but I'd really like to get rid of that hole right there. We're about there. Just a little bit more. I know that looks pretty strange, but it's going to work out. There'll be a steel plate mounted to the top of that will cover all that. Okay, I got some free metal here. Had a couple of cuts in it, and I'm going to try to TIG weld that and see if I can't use that. Okay, I got my tool post drill set at 3.5 inches, 3.5 inches in diameter. That's where I'm going to drill a bolt circle, 6 bolts. And I'm putting my gear indexing setup on to position the holes. Okay, needs to be 6 positions. Okay, the red dots represent 6 holes. Okay, what I'm doing here That's where the chucks will go. There'll be a lockdown drilled right there, right there. I'm trying to avoid this hole right here, so I'm going to make a bolt circle just a little bit off from that, far enough away to where I can drill a hole for the chuck right there. It's about 5/8 of an inch away. I think that'll work. Oh! Not good. Shit. Oh. Believe I got it. Okay, let's see if we can avoid doing that again. Okay, I located these holes with the indexer. Now I'm just going to finish them in the drill press. Okay, I gotta pay attention here because I could mess this up pretty easy. The holes where the arbor goes are threaded in this plate and they need to be clearance here. And I'm just gonna mark them. The other holes I gotta drill and tap. So these are clearance. Now, I'm a little concerned about drilling in this, but this is a clearance hole, so if it's a little out of line, moved a little bit. I can make that oversized though. Yeah, they're a little bit off. Well, they all start, and I could force them in there. Sometimes these socket head screws, the outer dimension of the thread is oversized. I've had that happen a couple of times. But they're all starting, so they're pretty close, but I'm gonna enlarge the holes in the countersink holes just a little bit. I like it. Well, that about wraps it up for today. I can't go any further because this is what I want to use to go right in there. That's 5/8 of an inch. This turret came with two of them. I can find this one, but I can't seem to find the 5/8. This is 1/2 inch. The 1/2 inch would probably work, but I think the 5/8 would hold better. Either way, I'm going to grind a flat right there and put a set screw right there, drill a clearance hole in that, and that's what will hold that from turning. That would probably be strong enough. If this is available though, I'd like to go with the 5/8. A whole lot more stout. That'll go in that far, and the set screw will go right into that recess. Anyway, thanks for joining me. Be sure and subscribe and ring that bell.